Earlier we examined the rendering pipelines with respect to buffers and where our code fits in. Now we're going to investigate the use of the other shader elements available to us, the Vertex shader and the Fragment shader, usually employed together. The Vertex and Fragment shaders give you a level of control over the shader that isn't available through the use of subsurface shaders alone. For example, so far we haven't been able to access or modify the vertices of a model with a shader, nor have we been able to base our shader code on the model's relative geometry, only its position in the world. The Vertex shader gives us access to each vertex in the model where you can set its colour or manipulate its position. The Fragment shader provides per pixel colouring, but can also access pixels relative to world position, allowing for a variety of techniques we've not yet been able to achieve. The structure of a Vertex Fragment shader looks like this. First we have the property block, as we've used before, followed by the subshader block. The CG program in this case is enclosed in a pass block. The required compiler directives include Vertex followed by the name of the Vertex function, and then Fragment followed by the Fragment function name. Multi-compile fog allows for the use of fog effects. If you aren't using fog, then you don't need this. Next, the unitycg.cginc file is included. This file contains all the pre-written methods and variable definitions that will make your life writing shaders that much easier. Feel free to locate the file in the shader source code and take a look at the contents. Following these are two structs to hold the data for the two shaders, one for the vertices and one for the fragments. These are not unlike the input struct used in the surface shaders we've already written. App data, used by the Vertex shader, contains information about each vertex. You can access as much or as little of the data as you need. Remember, coding for shaders needs to be tight, so if you don't need it, don't include it. The total sum of the values you can access can be found in the appdata_full struct found in the unitycg.cginc, and includes all regular values you should already be familiar with that go with geometry, including vertex position, normals, and UV values. You can also assign a colour to each vertex as well as get its tangent, a tangent being a vector that sits across a vertex at 90 degrees to its normal. The names you give to the properties inside the struct are inconsequential. For example, you could use pos instead of vertex. What is important are the keywords in capitals after the colon. These are the names recognised by the graphics card and align your variable names with those that will be used by your shader. The v2f struct is used by the Fragment shader. Like the app data structure, it can contain any and all properties that your Fragment code requires and can be taken from this list. It contains the usual suspects such as vertex and normal, etc. Note the way position is declared with SV position. This is because the vertex, after it has been transformed to screen space, has different coordinates as opposed to the position used in the app data. And SV position will only be accepted by some graphics cards. To put all this into context, we start with a virtual object in 3D world space. The data about each and every vertex is stored in the app data. This is processed by the Vertex shader, which projects the 3D data into the 2D clipping space and places values into the v2f struct. By the time the Fragment shader runs, the scene has been what I like to call squashed into the clipping space or clipping plane, which is basically flattening all of the coordinates into 2D. From here, the Fragment shader can calculate the colour of each pixel that needs to appear in the final screen render. Let's try making a Vertex and Fragment shader for ourselves. To create your first Vertex Fragment shader, create a project in Unity and add in Zombunny. I've got Zombunny with a standard shader on it and the albedo texture set to Zombunny's diffuse texture. Now, the Vertex Fragment shaders can be created if you go to Create and then drop that down, find Shader. You're looking for Unlit Shader. Remember, the Vertex shaders take away all of the background processing that's done by the surface shaders that we've written in the past. So lighting and that kind of thing isn't handled. You have to write your very own code to handle lighting and shading for these types of shaders. So that's why it's called an unlit shader. Now, if you click on that, it will create you a new version. Let's call it Basic VF. And we'll just open it up and have a look. Inside, you're going to find a basic skeleton structure of code that we've just gone through, which takes a property of a main texture here and then works through. It has the pass block, the vertex, and the fragment links up here to each one, your app data, your V2F structure, and then the main texture coming in, and also the actual writing of the shader code itself. Now, something to take note of is the way that the sampler to main tech is declared. So there's a sampler to, and there's also this float here, which has got main to underscore st written after it. Now, with any texture, Unity is going to give you the sampler to that we've used before, but also a float for that you can access. This float for contains scaling data for the texture as well. And this main text underscore st is actually used inside the Vertex program down here and refers to this one here. And if you were to take this out, this line, you're going to get an error saying that your Vertex shader doesn't know about this value here, which is a quite interesting fiddly little bit of syntax that you have to remember. So this one is in the Vertex shader and this one is in the Fragment shader. Now, after that, there is pretty much nothing else. It's the end of the shader. So once you've done that, just save it and go back into Unity, and you want to go over to Zombunny, find the shader itself, and look for this new one you've created, which is Unlit Basic VF, or whatever you named it. And it will automatically pick up the texture that you've already got and feed it through to the shader itself. And notice you don't get any lighting, okay? So it is an unlit texture, just giving you the basic colors of the texture. Okay, so that's how to write your very first Vertex fragment program and the bare bones of it. For the rest of this section, we'll look at building upon those and sort of gently introduce all the little elements that make up an entire Vertex fragment shader.